Hello, sixth graders. Welcome to our next math lesson. Today we're taking a look at lesson 38. It is talking about adding and subtracting decimal numbers as well as whole numbers. We're also taking a look at basically talking about squares and also square roots. And you're going to notice that the lesson for today is going to start on page 195 in your book. So before I get started on the lesson, I'm actually recording this video at home right now. I don't have my laptop hooked up to a smart board, and because of that, you're going to notice that there's this little watermark here. It's a note that basically saying, hey, you're using the basic version. If you hook up to the smart board, this thing will go away. Well, because I'm not hooked up to the smart board, this little thing over here is going to be on every single slide. So I'm going to try my best to kind of move the slide around to make it easier. But I will tell you that a lot of the stuff that is on this presentation here is taken straight from the book too. So if you have your book available, you can follow along that way too, and it might be hopefully a little easier to help to understand. So first of all, we're talking about dollar amounts. And you notice here I got $3, $3. And it says dollar amounts are often written sometimes with a decimal number like this. You see this $3.00. Sometimes it will be written without a decimal. It'll just say $3. Sometimes whole numbers are written the exact same as well. Sometimes they are written with decimal points and sometimes they're not. And you should notice here at the bottom page here, this would be the number 3. So sometimes you might see the number 3 written like this. And there's no decimal number here. Sometimes it might be written like 3 point, although I don't see this very often. It's possible I see this. I do see this written sometimes, like 3.0. Again, this just means 3. 3.0 is just another fancy writing 3. Or sometimes you might see 3.00. So all of these right down here, they're just a fancy way of writing 3. And what they're trying to show you is where the decimal point would be, even if I didn't write a decimal point in there. So like, for example, if I had a 3 here, the decimal point would be behind the ones place. Okay. Now, did I need to scroll? Yep. Okay. Yeah. Sorry. So use that information to help us solve a couple of these problems here. Paper used in school is often 11 inches long and 8.5 inches wide. Okay. The perimeter of that sheet of paper. Well, let's go ahead and add. We're going to find the perimeter. So if we find the perimeter of this sheet of paper, we're going to do that by adding the lengths of all 4 sides. So on a piece of paper, there are 4 sides. You know, if I quickly draw 1, 2, 3, 4, I know a really weird looking piece of paper, but you're going to kind of just go with me. So this side here would be 11 inches, 8.5, 8.5. So when it says to find the perimeter of this, we're going to be adding 4 numbers together. We're going to be adding an 8.5. So if I put an 8.5 here, I'm going to put another 8.5 here. And then I want to add 2 11s. And to make sure that I'm adding them correctly, I'm going to go ahead and add a decimal point, because like we learned in a previous lesson, when you go to add these numbers together, you want to make sure that your decimal points are lined up, okay? So those decimal points. So even though it doesn't say 11.0, I know that the decimal point is right there in my number, and that way I line them up this way. So if I add this up, 5 plus 5 is 10, okay, bring the 0 down, carry that 1 up there. I'm going to go ahead and bring that decimal point straight down so I don't accidentally forget to put it there. 8 plus 1 is 9, and then if I add another 9, that's 17 plus 1, which is 18 plus 1, which would be 19. So I'm going to go ahead and put a 9 there, and then carry 1 to the next column. 1 plus 1 plus 1 is 3. So you see that my answer would be, the perimeter that would be 39, and if I were to label that, I'd say 39 inches. Again, the main idea behind here is to recognize the fact that if I write 11 inches, the decimal point is right there. The same is true with this subtraction problem here. If I have 12.75, so I have 12 and 75 hundredths, and I want to subtract 5, sometimes people might accidentally do this. And if they do this, they're doing it wrong because they don't have the decimal points lined up. That's a lot of times what I see students struggling with is, well, there's a 5 there, so I'm just going to put it underneath there. But remember, this 5 is actually in the ones place. So a better way to write this would be 5.0, or instead of this case, maybe just saying 5.00, because since there's 2 digits behind there, you have 2 zeros behind there, and that might help us figure out where that decimal point's going to go. So this is definitely not going to go right there. I think we want to label it more like this, 5.00. Okay, so putting that decimal point in there hopefully is going to help you today. If you see a number that doesn't have a decimal in there, put that decimal in right away so you don't get too confused. And then subtract 5 minus 0, 5, 7 minus 0, 7, bring that decimal point down. This becomes a 0, which that becomes a 12. So 12 minus 5 is 7. So this answer would be 7 and 75 hundredths. So again, this first part of this lesson is, being able to add and subtract decimals and whole numbers. You may have to put a decimal point in there, like in this 5, you have to put the decimal point there. For this 11, you have to put the decimal point there. But just kind of watch that, students. If you notice that one of them has a decimal in it and the other one does not, that means you personally have to put that decimal point in there to make sure it's put in the right spot. The other part of today's lesson is talking about squares. And it says, recall that we find the area of a square by simply multiplying the length of the side of the square by itself. And the reason why we're doing multiplying by itself, because in a square, all sides are the same length. So for example, if I had the area of a square that is 5 centimeters long, what I would do is I would take 5 centimeters and multiply by another 5 centimeters. That means that the answer would be 25 square centimeters. And I kind of illustrated that here. Like, here's my square. The side length is 5 centimeters. So if I want to find the area, which is everything on the inside, I just take 5 times 5. From this model square here, that comes to the expression. By seeing this model here, that's where the expression comes from, squaring a number. Maybe you haven't heard too many people saying squaring a number yet, but I guarantee you, as the farther you go along in mathematics, especially in 7th and 8th grade, algebra, algebra 2, those areas, you're going to hear a lot of people talk about squaring a number. So we square a number simply by multiplying the number by itself. So if I'm going to square this number, I'm going to 5 squared. What I'm really saying is I'm taking 5 times 5. So if you hear someone say, well, 5 squared, that just means 5 times 5, and that'd be 25. So if I said something like 3 squared would be like 3 times 3, which would be 9. Okay, so anytime you hear some number squared, that means you're just taking that number and multiplying it by itself. Okay. To indicate squaring, they would use an exponent. We have talked about exponents before, and the exponent we'd use there is a 2, which is squared. So a lot of times you'll see this, a very big 5 with a small little 2. This is the exponent right here. And this exponent here does not mean take big number times little number. The little number tells you how many times you need to multiply the big number. So if this number is a 2, that means I need to take 5 times 5, and 5 times 5 is 25. Okay, so we would say that 5 squared, because 5 times 5 is 5 squared is 25. Okay, now an exponent shows how many times the other number, which is called the base, is used as a factor. So in this case, 5 is multiplied twice, like I mentioned before. So here's a couple examples of what I'm talking about. What about if I said, what is 12 squared? We just learned that this word squared means I'm going to take a number and multiply by itself. But the question becomes, what number am I going to multiply by myself? Let's give you that number out front. So 12. If I have 12 squared, that means I want to take the number 12 and multiply that by another 12. Okay. And I'm going to take 12 times 12, and 12 times 12 is 144. So this would not be 24. Some people might be tempted to say, oh, I'm going to take 12 and then add another 12. Do not add. Do not do that. Get rid of that out of your mindset. This squared means multiply. 12 times 12, 144. Then you might see problems like this. As a matter of fact, I know you will see problems like this today where they want you to simplify this. And anytime they say the word simplify, that just means find the answer. We want to get it down to one type of numeral answer. So this here I have 3 squared, and then I'm going to add onto that 4 squared. Well, some people might be tempted to take 3 plus 4 first and then square it afterwards. But actually what you want to do is you want to make sure you do the squaring first before you add. If you remember the please excuse my dear Aunt Sally, there it tells us we want to do exponents first before we do any addition. So this right here, we're going to take 3 squared. Oh, you hear that word squared again, right? 3 squared. That means 3 times 3. So 3 times 3 would be 9. So 3 squared is the same as 9, okay? And now I'm going to take 4 squared. 4 squared, that means 4 times 4, which is 16, okay? And now I want to add those two numbers together, 9 plus 16, and that's going to give me 25. So 25 is my answer, okay? So let's say, for example, someone messed up and actually accidentally added first. Let's say they did 3 plus 4. Well, 3 plus 4 is 7. And then if you square 7, 7 times 7 is 49. That does not get me 25. So that's why you want to make sure that you don't add first. Get rid of these squares first before you add, and that'll get you the right answer. Okay, so determine the length of a side of a square from the area of the square is a model for finding principal square roots of a number. Now that's pretty confusing. What did you just say? Okay, finding the square root of a number is the inverse or the opposite of squaring a number. So for example here, if I take 6 squared, well, I already learned that the word squared means take a number multiplied by itself. So 6 times 6 is 36. So 6 squared is 36. To find the square root is doing the opposite of this. So what I'm saying is that the square root of 36 is actually 6. When I say square root, that means the opposite, which means what number when I multiply by itself gives me 36? Well, I know that 6 times 6 is 36, so that means the square root of 36 is 6. Now, when we talk about square root, there's a symbol that we use. It kind of looks like a division symbol here, but there's a couple key features about this that we know that's not a division. Number one, it's kind of got like a check mark look to it, and then a slant over. And number two, there's no whole number out in front to divide by. Okay, so we would read this number right here as the square root of 100. So if you ever see this little slanted line here, this means the square root. So if I saw this, I'd say the square root of 100. Okay, this expression basically means what positive number, when you multiply it by itself, has the product of 100. So you got to kind of go through it. What number, when I multiply by itself, gives me 100? Well, since 10 times 10 I know equals 100, that means the principal square root of 100 is 10. So a fancy way to write that would be, what is the square root of 100? Square root of 100 would be 10. How do I know that? Because if I take this number and multiply by itself, it should equal what's inside that square root symbol. Okay? It says a number is a perfect square if it has a square root that is a whole number. So if we start with the number 1, the first 4 perfect squares are 1, 4, 9, and 16, as illustrated before. So let's say, for example, I have a square that has one side times one side. 1 times 1 is 1. Well, what's the square root of 1? The square root of 1 is 1, because 1 times 1 is 1. Here's another one. Here's, I got a square here. It's 2 units high and 2 units long, so it's taking like 2 times 2, which is 4. Okay, so if I said, what's the square root of 4? Well, 2 times 2 is 4, so the square root of 4 is 2. Here's another square here. I've got it's three blocks going high, 3 blocks going long. So I take 3 times 3. 3 times 3 is 9. So if I asked, what is the square root of 9? Square root of 9 is 3, because 3 times 3 is 9. Here's another one. If I did a box that's four boxes high, 4 boxes across, 4 times 4 is 16. So I'm going to ask, well, what's the square root of 16? Square root of 16 is 4, because 4 times 4 is 16. So whatever number's inside this square root box here, this symbol, you just got to ask yourself, what number when I multiply by itself gives me that number, and that's what it is. Okay, so here's a couple of examples. Let's say, for example, I want to simplify this. Let's simplify square root of 64. What I'm asking for is, what number when I multiply by itself gives me 64? And you got to kind of work through your multiplication facts. Well, I know that 7 times 7 is 49. Oh, that's not big enough. What if I try 8 times 8? 8 times 8 is 64. Oh, 8 times 8 is 64. So that means I would need to simplify this. So the square root of 64 is 8. Okay. Now you're going to use this today because they might actually ask you to subtract some square roots. Just like you did on the previous page. Before I go subtracting these, I probably should undo the square roots first. Okay. So let's take a look at the square root of 81. And the square root of 81 would be, okay, what number would I multiply by itself to give me 81? Well, I know that 8 times 8 was 64, so maybe we should try a number that's bigger than 8. If we go 9 times 9, 9 times 9 is exactly 81. So if I said, what's the square root of 81? The square root of 81 is 9, because 9 times 9 is 81. So I'm going to do the same thing here. What's the square root of 49? I got to ask myself, what number, when I multiply by itself, is going to give me 49? And that's going to be 7. So the square root of 49 is 7. So what I've done is I've undo the square roots first. Now I'm going to go ahead and subtract. So square root of 81 was 9. Square root of 49 is 7. Now let's subtract this. 9 times 7, 9 minus 7, and then answer is going to be 2. Okay, so make sure you undo the square roots first before you do any addition or subtraction today. Now in this lesson earlier, I told you what the first 4 square roots were, because 1 is a square root because that's 1 times 1. 4 is a square root because that's 2 times 2. 9 is a square root because that's 3 times 3. And 16 is a square root because that's 4 times 4. The book's going to ask you, what are the next 4 perfect squares? Well, if this is 4 times 4, I'm going to have to go to what is 5 times 5. 5 times 5 is 25, so 25 is a square root number. Okay, the next number would be 6. If I take 6 times 6, 6 times 6 is 36, so 36 is a square root number, okay? Next number I do is 7. So I want to take 7 times 7. 7 times 7 is 49, okay? And then I want to do 8, which is 8 times 8. 8 times 8 was 64, like I mentioned earlier in this lesson. So if I said, what are the next 4 numbers that are square roots? Here are the 4 numbers that are square roots, okay? All right, so your assignment for today's 6th graders is to do pages 198 and 199. There are quite a number of practice set problems. I think there's like 17 of them. So your assignment is just to do letters A through 13, okay? If you have any questions with this, don't be afraid to go back, look at the video, look in your book for some examples. As a matter of fact, if you look at one of the problems I did on the previous page, that'll probably help you with at least one of the practice set problems that you see there. So don't hesitate to reach out to me if you need some help on anything. I'm here to help the best that I can. Hope you guys do good luck on your lesson for today, and we'll see you with the next video.